That's fine. So my name is Brian Brazel, and just to give you some background, I am one of the core developers of Prometheus. I also found Robust Perception, who's trying to do the open source thing around Prometheus for consulting and support. Maybe it'll work, maybe it won't. I'm also a local here. We're actually just up the road, and I used to work in Google as well, that direction as well. So when we're talking about monitoring, different people have different meanings for the word monitoring, so it's important to distinguish what exactly we're talking about. So the first thing is knowing when things go wrong, more commonly called alerting. Some people think monitoring is only alerting, but in reality there's more to it than that, because once you get your alert, you need to debug. So you need dashboards where you can look at the here and now, see what's going on, and fix the problem to make your users happy. Then in the medium to longer term, you want to instrument all your applications, get more information about them so you can make business decisions, so you can make technical decisions, so you can do capacity planning. And the fourth one is plumbing, which isn't technically monitoring, but as soon as you have, a hammer, everything starts to look like a nail, and people really like to use the monitoring system just to move data from A to B just because it's there, because you all know that's going to happen anyway. So the philosophy that Prometheus comes from for monitoring is that if you consider, say, your microservice architecture, and you've got some tree of services, if you look inside any one of those services, you have a similar tree with all the internal libraries and subsystems, and each of those have things that are interesting to monitor, just in the same way there's RPCs and API calls going on outside your service. So the idea of Prometheus is you instrument each of those, and then our client library code pulls that all together and pulls it into Prometheus. And we go a step further, we don't care about individual instances. We care about services. So you can imagine if you had a cluster of read-only MySQL slaves, and you had 10 of them, and one of them was down. But the other 9 are working fine, and customers are happy, and latency is okay. So why would you wake someone up in the middle of the night for that? They can deal with it in the morning. So that sort of thing, looking at is the user actually impacted, rather than just waking people up in the middle of the night just because something is wrong, but not urgently wrong. So Prometheus, in this context, is a few different things. It is a metrics monitoring system, not a logs-based system. So the previous talk there, or 2 talks back by Cloudflare, looking at all those DNS queries, those are logs, individual events. Prometheus wouldn't get that. It doesn't store those. You need a log system for that. What we'd be looking at is, hey, in the last 5 minutes, there were however many, 150 million A queries, and so many quad A queries, and so on. And that's sort of general statistic of what's going on. And then once you know generally which subsystem has a problem, you can jump to logs and figure out which user you need to have a nice little chat with. It's also a time series database. This is a database conference. There has to be a database in there somewhere. There's a query language, client libraries, and unique system around it. And the general approach we're trying to encourage people to follow is a more modern approach to monitoring services. So just to give a quick look at the architecture of Prometheus, it is a flow-based monitoring system. So we talk something like Kubernetes, console, EC2, or whatnot, get a list of everything that wants to be monitored. We've got to scrape it, whether it be your application, whether it be an export or something like MySQL, or push it into your batch jobs. Store that locally on SSD. It's just a single server, it doesn't talk to others. There's rules and alerts then. You send it to the alert manager, which goes to PagerDuty, Slack, whatever else you want the notification for. And then there's tools like Grafana, which can use the HTTP API to show graphs. So the client libraries allow you to instrument your code, because the most value you can get out of this sort of system is to know what are effectively business metrics, but in an engineering sense. So like, what is the latency of this library? It's like, oh, this library is the slow one. Maybe I'll optimize that. Because first you should always measure before optimizing. And understanding that sort of thing. Another advantage to the way we look at things is that you're going to be using a pile of open source libraries. If one of them happens to have already instrumented itself with Prometheus metrics, well, you get those for free. So it only has to be done once rather than you having to go and change that code. And even if you aren't using Prometheus and you're using a different monitoring system, you can still access those metrics and pump them out, which is handy. And there's also a pile of exporters, because let's be honest, it's not particularly likely that Prometheus metrics will end up exported from MySQL. Maybe it'll happen, but it's very unlikely to say Linux. So there's exporters like CAdvisor for your Docker stuff, or MySQL, Mongo, SNMP, JMX. There's like plenty of these. Even Minecraft and Factorial. The Minecraft one is actually done by a friend like 30 minutes down the road because he likes a lot of mods. They eat a lot of CPU. He just wants to know what is, make sure his FPS is okay. because he's simulating several computers in there. So the query language itself, it's not based on SQL, because even though it's got QL in there, because all query languages have to have QL in the name. It's just a rule. But SQL isn't too great for time series data. You need something a little more bespoke, which is what we have. And it lets you do all sorts of joins, aggregation, all the stuff you normally want to do with time series data, is operational time series data. Now, it wouldn't be useful for day-to-day, CRUD stuff at all, but it's good for analyzing this sort of data. So it's nice and science, it's good for what it's for. You can predict quota, so how close you are to filling up your disk space, rather than having to choose 10% or 1 gigabyte as your threshold. You can just say, hey, will it actually fill in 4 hours? And another big thing in Prometheus is the graphing and alerting are unified. So the alerting language is the exact same as the graphing language. So you can just graph your alerts and see how often they fire, which is handy when creating them. So here's just one example of a query. This is a reporting or analytics query for long-term stuff. Here we're using container CPU usage seconds total, which is a bit of a mouthful. That's a Docker stat or a C-advisor stat. We're getting all the Docker images, telling me, hey, what's the average CPU usage over the last 5 minutes per second? And then add that up by Docker image. Not by team, not by service, not by production versus dev, not by region. We're cross-cutting across all of that in Docker image and tell me the top 5 most expensive ones. And then you could go and say, hey, here are the Docker images that are using the most CPU. Maybe we should optimize those a little bit, save ourselves a bit of power. So there you can just focus your engineering effort. We're going to get the most returns in terms of saving resources or whatever else your business goal is. Once you have alerts, though, well, not every alert results in a page. Consider that you had a rack failed, and there's 40 machines in it. Do you really need your pager to go off 40 times for that? And that's not particularly useful. So the Prometheus Alert Manager groups alerts together. So you can say, right, my unit of grouping is the rack. So you'll get probably 2 notifications for that. One where it spots the first half, one where it spots the second half. Maybe even just 1 notification. I might decide instead, hey, wait, let's just have 1 for the entire data center, because I don't need to be notified that often when we lose lots of machines. We've also got a HSH solution, which is kind of handy. It's not a CP design, it's an AP design. So if you have a network partition and at least one side can still talk to the internet, you're going to get paged. If both sides can still talk to the internet, you're getting double paged. But that's better than getting no pages, especially in a network partition. In terms of general philosophy, then, what does all this allow for? If we look over the last 10, 15 years of where we've been going with system administration, it used to be in the day, you were managing your handful of machines by hand. And if you were lucky, there was documentation in a wiki maybe, those brand new wiki things back then. And that was what you had. And then if we look back maybe 10-ish years ago, we started to see things like Chef, Salt, Ansible, Puppet. And we started to automate things at the machine level. And now we're going to things like Kubernetes, where we're kind of forgetting about the machine. It's like, actually, why do I care about debs and RPMs? I just want this binary to run. And we're then managing everything as cattle rather than pets. And we need to do the same thing about monitoring. I see lots of people going to Kubernetes and it's like, yeah, we're going to do this Kubernetes thing, it's going to be great. So how do I alert on load average? It's like, and CPU usage, which is not something you should be caring about in a Kubernetes machine, because you say how many resources you want. And if I'm in that sort of environment, and I've hit 90% CPU usage on a machine, that's awesome. I was paying for that, and it's being used. That's wonderful. So what we need to care about when alerting is what matters to the end user, not just things that might be wrong or might have to have a human to look at it. Because let's be honest, humans are expensive, and they burn out. So we need to think about where we can actually get a good return in terms of alerting and investment in time. Because at the end of the day, monitoring is a means, not an end. Your business goal is your end, unless you're a monitoring company. So the community as well of Prometheus is pretty rich. Apparently, we're the 58th largest open source community by contributors. And the top one is like Linux, unsurprisingly. But this is pretty impressive for a project that's only been around for about 5 years. Over 200 third-party integrations, hundreds of people involved in the list, and we're estimating about 500 companies using it in production. It's a little hard to count with open source, because no one tells you, we've got no beacons or anything. But we figured it out. So you might be wondering, do I know anyone using Prometheus? There's a company called Percona. You might have heard of them. They're a small little consultancy gig. But Percona Monitoring and Management, as already mentioned, uses Prometheus. Also Cloudflare, Google, a few others as well. So Prometheus, as I said, it is a metrics rather than logs, time series database, query language, client libraries, and a vast ecosystem as well to go with it. And we're trying to encourage a modern approach to monitoring. And there's a whole pile of links there, including our blog, which uploads once a week with the latest stuff on Prometheus. Thank you.